Good afternoon, Year 10s. I hope you're all well and enjoying your Friday afternoons. Now, today is a little different in that I'm not actually in the classroom, but other than that, the class will run as close to normal as possible. So, in keeping with that, can you please get out your notebooks? Now, while you're getting out your notebooks, I should say a couple of things. When I'm teaching a class, you guys can slow me down and stop me when I go too fast as I'm making notes. Here, if I start going too quickly, and I will, please raise your hand and ask the relief teacher to pause the video. It's great, you can pause me, you can literally rewind me to cover the things you've missed. Alright? Now, can you please write down the heading of solving simultaneous equations by elimination? So, yesterday we discovered how to find where graphs or lines meet graphically, and to find where they meet using a method called substitution. Now, for those people who were away yesterday, over the weekend you need to log on to Simon, find the lesson recording from yesterday, watch the lesson, take notes, have a go at the examples. Because I'm afraid today won't make a huge amount of sense unless you know what's happening from yesterday. And I did email you to remind you about that. Alright, so take an example from yesterday. To solve this using substitution, we recognise that y is all by itself, and y is equal to 4x plus 1. So in the equation underneath, we can take the 4x plus 1, we can take the y and throw in 4x plus 1 in its place. The result being that we write an equation that only has one variable in it. It may not look particularly pretty because my handwriting is atrocious, but it only has x. So we can expand and simplify, meaning we have 2x take 12x take 3 is equal to negative 23. We collect like terms. Negative 10x minus 3 is equal to negative 23. Then we start unwrapping x, if you like. So minus 3 is the furthest away. We add 3 on, giving us minus 10x is equal to negative 20, and therefore x is equal to positive 2. Now remember, this wasn't the entire solution because we wanted a point where they met, and so far all we've got is the x coordinate. So what we do is we take this value of x, we substitute it back into this equation, and we can say that y is equal to 4 lots of 2 plus 1, or that y is equal to 9. So our point of intersection will occur at 2, 9. And you can check that graphically if you wish. Now this system or method of solving only works because we have this beautiful y by itself and we can make a substitution easily. Now yesterday we did tackle some problems where we did some rearranging to get a y or an x by itself and then substituting. But today I'm going to show you a shortcut that means we don't have to rearrange in order to solve. So for example, if we came up against this sort of problem here with no x's or y by itself, it would take quite a bit of work to get one of them by itself, and then the substitution would look ugly. So, can you please take down those two very, very basic equations? And, so you know what I'm talking about, I'm going to call them 1 and 2. Okay? Now I'm sure we can all agree that, well, 7 plus 8 equals 15 and that 13 minus 9 equals 4. But what's very cool is we can take equation 1 and add it to equation 2 to give us an entirely new equation. And what we're going to do is add the terms that are above each other, essentially. So we have 7 plus 13 is 20. 8 plus minus 9 is negative 1. And this is equal to, well, 15 plus 4, which is 19. So we have an entirely new but completely legal equation. We can take two equations together and add the left-hand sides together, add the right-hand sides together, and what we get is a third equation that is perfect. It's completely allowed. Even more incredibly, we can take one equation, say equation 1, and we can multiply it by 2, And that leads us to 2 lots of 7, which is 14, plus 2 lots of 8, which is 16, and that is going to equal 2 lots of 15, which is 30. Alright? And then if we wanted to, we could take this new equation and add on equation 2, and so on, and we would keep creating new equations. You've done this before, because you all know that what you do to one side of equation, you can do to the other. So if you multiply the left-hand side by 2 and do the same to the right, you still get the same equation. But this, you won't have done before. But hopefully you can all see that the logic still works. If we add 2 valid equations together, we end up with a third similarly valid equation. Now, how is this useful to us? I'll explain. Can you please take these examples down? Once again, I'm going to label the equations 1 and 2. And when you're doing the working, both in the test and assignment sheet, I would like you to label them 1 and 2 as well, simply so whoever's marking or looking at your work knows what you're doing, and so your working is nice and clear and you can follow your own train of thought. Now, if I add 1 and 2 together, we're going to get a third equation, and we're going to see something quite interesting happen. So I'm going to say 1 plus 2 results in, well, this. X plus 3x is 4x. Positive y plus negative y is 0. 6 and 10 is 16. Now what we've done is we've eliminated the y variable, and that's why we call it the elimination method. If we add 2 equations together and we do it in the right way, we can essentially eliminate a method, leaving us with a very simple equation to solve. Clearly here, x is equal to 4. And then to find y, we substitute x equal to 4 back into one of the equations, and then that will give us, well, 4 plus y is equal to 6, or y is equal to 2. So that's our solution. And it came from choosing the right operator to put in here to add the two equations together. Now it seems strange, but we won't always choose to add. It works equally well if we subtract. Take the example on the right, for instance. If we added equation 1 to equation 2, we would have, well, x plus 2x is 3x, and y plus y is 2y, which doesn't help us hugely, because we still have x's and y's and we haven't eliminated any. But if we do equation 1 minus equation 2, we get x minus 2x, negative x. We get positive y minus positive y. Now that's beautiful, it disappears. Y take y is 0. And we get 2 minus 7 is negative 5. Minus x equals negative 5, so x is 5. Then we sub in. And it doesn't matter which equation we sub into, I'm just choosing the one that looks the easiest, because it normally works out nicely for us. If x is 5, that reads as 5 plus y equals 2, therefore y is equal to minus 3, giving us a solution of 5, negative 3. Alright, the key to this is being able to look at the two equations, label them, and choose what operation to do, such that you eliminate one of the variables. Alright, those are two quite simple examples. It gets a little more complicated. For example here, once again, please copy them down. We have 5 examples in total and we're 2 down, 3 to go. If I just added equation 1 to equation 2, or took equation 1 from equation 2, I couldn't actually achieve anything. I wouldn't be able to eliminate a variable. However, if I do equation 1 minus 2 lots of equation 2, we get something interesting. What I'm doing is, I've seen that on the top there's a 2y, and wouldn't it be great if we could take away a 2y? Unfortunately, there's only a y, but we can multiply the entire equation by 2 to make it a 2y. Alright? If you want to, you can think about this in 2 steps. You can take this equation here and multiply it by 2. Remember, what we do to one side, we can do to the other. So there would be nothing wrong at all with saying, well, that whole equation 2 multiplied by 2 would be 2y minus 6x is equal to 2. Alright? We then take this, which is 2 lots of equation 2, and add it to equation 1. So 2y, subtract it from equation 1. 2y minus 2y is our 0. 5x minus negative 6x. The double negatives is something to watch out for here, because if we're doing 5 minus negative 6, that gives us 11x, and 13 minus 2 is equal to 11. So x equals 1. We then substitute back in to find y. I'm going to substitute it in to this one here. And that leaves me with y take 3 lots of 1, which is 3, is equal to 1. Sorry, I meant to write y and wrote the answer. Y is equal to 4. Okay, so we're doing the same process as before. We are either adding two equations together or subtracting one from the other. In our case, we subtracted one from the other in order to eliminate a variable. The only trick here was that we had to multiply one of the equations by 2 first to get it into a good place for us to carry out the subtraction. Alright, take a look at this one. Have a think about what you would do to get this lined up nicely in order so that when we add or subtract one equation from the other, it will work. What I would recognise is that we've got a minus y and a minus 2y. And wouldn't it be nice if they both had a 2y term in front of it? So I'm going to take this equation here, equation 1, and I'm going to take equation 1 and multiply it by 2. I'll do this in 2 steps. Equation 1 times 2 will give us 10x minus 2y is equal to 2. I'm then going to do our new equation 1, which is that there, plus equation 2, and add them together. Now that gives us 10x plus 3x is 13x. It gives us negative 2y and negative 2y. Careful, I've made a mistake. The mistake I've made is if I take negative 2y and add another negative 2y, I'm going to get negative 4y, which wasn't what I was aiming for. So my mistake was to add them together, when really I want to subtract. So what I'm doing is I'm doing equation 1, which is this one, 10x minus 3x is 7x. Negative 2y minus negative 2y becomes negative 2y plus 2y, which is 0, and that is equal to 2 minus negative 5, which is 7. So x is equal to 1. I'm then going to take this, substitute it back in. 5 times 1 minus y is equal to 1. Y is equal to 4. Alright? So this is why I was encouraging you to label your equations carefully and think about the sign you will use between the two equations, because it's very easy to make a mistake. Alright, last one, and the hardest. And I apologize if I'm going quickly. Now here, looking at it, you can't take one equation and multiply it so that the numbers line up. So for example up here, we were able to take the first equation and multiply it by 2 to get 2 lots of 2y. And in fact we did a very similar thing with our first example also. But here that's not an option. So instead we have to aim for a common multiple. I need to multiply this equation, equation 1, by something and equation 2 by something so they line up. Once again, I'm going to try and eliminate y. So wouldn't it be nice if both of those were 6y terms? And that's what I'm going to aim for. So I want to multiply equation 1 by 3, and that will give me 9x plus 6y is equal to 18. And I'm going to multiply equation 2 by 2, and that will give me 10x plus 6y is equal to 22. Alright? So we have a new equation 1 and we have a new equation 2. Now, those 6y and 6y have to go. So I want to say, well, I'm going to take equation 1 and subtract equation 2. So, 9x take 10x is negative x. 6y take 6y, well, that's gorgeous, it drops out to 0. 18 take 22 is negative 4. So we have negative x equals negative 4, x equals 4. And then we can substitute this in to either one of our equations. I'm going to choose that one. 3 times 4 plus 2y is equal to 6. 12 plus 2y is equal to 6. Take 12 from both sides. 2y is equal to negative 6. Y is equal to negative 3. Our solution, therefore, is x equals 4, y equals negative 3. So recapping, we have adjusted both of the equations to set up this pair of 6y's. Equally, we could have set it up so that we had a pair of 15x's. Either way, we could have eliminated them by doing this step here. Alright, so have a go yourselves. Go to page 58. It starts off nice and easy. Questions 2 and 3, do all of them. 4, 5, 6, 7, 8, 9, enjoy. You have a double, so make the most of your time. If you finish early, you can then start the homework sheet, which should have been handed out to you. This homework sheet is due next Friday. Alright, if you're still struggling, ask other people in the class, help each other, look back at the examples in the textbook, the examples follow it through nicely. And remember, you can always use method of substitution or solving graphically, which will still get you the same answer, it just won't be elimination. And I should give you a word of warning that you will need to know all three methods, substitution, graphically, and elimination, because it will ask you to do specific ones during the test. And what we covered today is elimination. Alright, good luck, and I will